name is Nick Hyman, and I'm here to teach you about the 8th grade VSVS lesson, Electromagnetism. Start off by introducing the lesson and asking, what is a magnet? Students should observe that magnets have two poles, and the like poles repel, and opposite poles attract. On bar magnets, the opposite poles are on opposite ends. With a bar magnet, you can show electric fields with iron filaments. Those are the field lines of the bar magnet. Next, ask the students if they've heard of an electromagnet and take the answers. Explain that an electromagnet can be made by wrapping copper wire into a coil and running an electric current through it. Electric current is the movement of charge, as the students learned in previous lessons. The movement of electric charges creates magnetic fields, so when the current runs through the copper coil, a magnet is produced. Explain that this is a temporary magnetic field and it will only be present while the wire is connected to a battery. This is the main characteristic of an electromagnet. Next, the students will be testing the strength of two different electromagnets. First, test the nail to make sure it is not magnetic. Try picking up a paperclip with it. That one's good. It shouldn't work, but if it does, tell the students to tap the nail against the table until it is demagnetized. Now the students will create the circuit shown on the instruction sheet. Snap two wires into a switch. Clip one wire on the metal bar from the battery holder. Clip the other end to the coil on the nail. Now take the last alligator clip and complete the circuit by attaching it to the battery. Ask the students what to do to complete the circuit, then press the switch and see how many paper clips will stick. Make sure they know not to hold the switch down for too long because it could hurt the batteries, and then repeat the process for the other nail. Because this only has 10 coils, it should not be as magnetic and may not even pick up any magnets, any paper clips. Ta-da! Next, the students will be comparing the properties of electromagnets with permanent magnets. Pass out the electromagnetism circuit board kit and have the students connect the circuit board based on their instruction sheet. Tell them to notice the number of coils around the electromagnet and ask them to predict whether it will be stronger or weaker than the other electromagnets, and why. Test the two paper clips first with the permanent magnet, and then show the students the test with the electromagnet with the circuit on and off. Now we are going to test the magnetic field with iron filings. Shake the iron filings around to randomly disperse them and hold the magnet close. Now, redisperse the filings and hold it near the electromagnet and turn it on. Compare the lines and ask the students if they see any difference. Mention that the same shape of lines were formed, but they were fainter with the electromagnet because it's weaker. Next, tell the students that electricity and magnetism are complements of each other. That means that they're connected to each other through very complicated physics, but in the same way that an electric current can induce a magnetic field can induce an electric current. Create a circuit with a meter in it, like the instruction manual says. Explain that this meter can measure both voltage of the circuit and current. Set the switch appropriately to the middle setting so it will detect the very small amount of current we're about to create. First, place the magnet near the coil and move it to see if the meter moves. Repeat with the iron bar in the middle. There's very small movement of the meter. Now with the bar in the middle. And the magnet on top moving it up and down. You can see a very faint movement of the meter. Now you're going to talk about the applications for electromagnets. Pass out the materials and make sure that the students can identify the battery, the magnet, and the copper wire loop. Show the students that the coating on the copper wire has been removed on the top half of one side of the wire. Now, that will be able to conduct electricity. Now place it in the top part of the battery, and if it doesn't start spinning immediately, give it a gentle tap. To explain this, note how the electricity is flowing through the coil, making an induced magnetic field. The property of magnetic fields is that the same signs repel and opposite signs attract. The loop is repelling the magnet when the coated side of the wire is in contact with the battery and the current is flowing through it. When it flips, the wire is no longer in contact and the battery is no longer creating a magnet. So the momentum carries it over to the starting position and then the cycle continues.